Okay, so let's start the session. Let's start the class. Also, is there any CR here in this section? In this session right now? Is there any
Yes, ma'am.
CR? Maruf? Yes, Maruf, you are the CR. And anybody else? Anybody else? Okay, so Maruf, I'm adding you as a co-host. Your task is to add the students who are who will be giving joining requests. So your task is to accept the requests.
Okay, ma'am.
And anybody here who can record the session as a recording device.
Yes, I will. I
Okay.
will be recording
Hasna,
this.
okay, thank you so much. So please record the session. And okay, okay. So I'm presenting the session. So please, okay. Can everybody see my screen?
Yes, ma'am.
Okay. So remember in the last class we studied SLR1 parsing. We learned how to build the SLR1 parse table, but we did not go through the parsing process. So the parsing process will be later discussed because the process is going to be the same for all kind of LR parsers. So we are going to study two types of LR parsers. One is the simple LR or the SLR, and the other one is the complex LR or CLR. So we're going to study two parsers, SLR and CLR. Now, the CLR1 parser is also known as LR parsers or LR1 parsers. So the C here is not used every time. Okay, so the C here may or may not be used. So normally by LR parsers we mean CLR parsers. So simple LR is another version of an LR parser. Okay. Okay. So now, why do we use LR1 parser in case of CLR1 parser? This is going to be your home task. So I'm going to ask you this question on Thursday. All right, Thursday we're gonna have a quiz, and as well as I need you to answer this question. So there might be some kind of bonus or in some kind of rewards for the students who will be able to answer this question, which is why do we prefer to use a LR1 over SLR1? Okay, so this is a question, um, and I need you to answer this question correctly in the next class, in the um, offline session. Okay, the answer is actually given here in the PDF, but it's a bit it's given in a bit complicated way, but with different Greek letters and symbols here. So your task is to understand that and then make it a bit less complicated, make it a bit more clear. Okay, so let's move to SLR1 parsers. Okay, so I cannot find a slide for LR parser. Okay, so here's our LR1 parser. Now, so we prefer to use LR1 parsers over SLR1 parsers in some of the cases due to some kind of reason. And again, this is a pop quiz for you, which is you need to answer that on your own. But let's move on to the mechanisms of LR1 parsers, meaning how we can implement LR1 parsers and how it's different from SLR1. So our SLR1 parser used a kind of automation which was also known as the LR0 automation. LR0 automation. On the other hand, our LR1 or CLR1 parser uses LR1 automation. So the main difference between the two of the parsers is the kind of automation that they both use. Now, these two automations, LR0 and LR1, they're both semi-deterministic automations. But the difference here is that LR0 automation only contains LR0 items and LR1 automation contains LR1 items. The rest of it is the same. So an LR0 item is of the form like this, right? A derives like this, something like this, alpha dot, right? Or the dot can be anywhere in the production body. So an LR0 item is a production rule with a dot in the production body. This is what an LR0 item is, right? But an LR1 item will have two components to it. So an LR1 item will have a production body with a dot, an item definitely, and it will also have a look ahead symbol. So it will also have a terminal or a look ahead symbol. So there are two parts to an LR1 item. So this part before the comma is called the core, and the part after the comma is the look ahead. Okay, but in case of LR0 item, we do not have a look ahead symbol. So that is why it's written 0, meaning no look ahead is present. But here in case of LR1, we see that it's we have written 1, meaning that there is one look ahead symbol. So this is the basic difference between the two kind of automations. Other parts are the same. Now, because of this difference, some changes need to appear in the closure function. All right, because these two automations are going to consist of states and transitions. So that is why the closure function is giving me states, right? And the states are going to consist of some items. And the items that we are generating for each state are going to be a little bit different because here the items are going to have two parts to it, right? Two components. So let's see what the changes are. So again, an LR1 automation will be a DFA-like structure or a semi-DFA, but it will have two functions that will help us evaluate the states and the transitions for the semi-DFA. So we have a closure function just the same as the LR0 automation, and we have a go-to function. So these two functions are needed to evaluate the LR1 automation. Now here, um, we see that the closure function, remember the closure function of the SLR0 bar, or sorry, LR0 automation. So the closure function What it did was it took an item I, and then it actually gave us a state as an output, which was denoted by some ik, where k is an integer. So k can be any integer from 0 to n. So this was the definition for closure function. It's going to take an item I and it's going to enclose that item in a state, and the state is marked by ik, where k is an integer number. Okay, so now moving to the closure function first. Remember what was the rule 1 for closure function? Does anybody remember the rule 1 for closure function? Any responses? No responses? Anybody remembers? So the pros of online classes is that you can attend the session anywhere from your home, you from anywhere, right? Anywhere. How you don't have to be present in the university. And also the commute time is saved, and also money is saved, because if you're commuting with the help of an Uber or something else, then you do not need to spend money on that. So these are the pros of online sessions, which is beneficial to you and to me, both of us, right? For the teacher, the instructor, and the students. The cons of this kind of sessions is that I know some of you are sleeping, and some of you are probably having lunch or like a breakfast, but these things are not visible to me. So some of you are not even paying attention to what I'm saying, because this class is recorded, so you're gonna turn on the session and then after the class, and you're gonna learn from it. So that's the problem, because in the online session I cannot make it interactive like I can do it in the offline ones. So I would really appreciate it if someone gives a heads up, or someone gets any kind of nods or responses, so that I know that at least some of you are present listening to me. Okay, thank you, Hasna. Okay, so I'm also not I'm not belittling you, or I'm not scolding you, because I, as a student in my online sessions, tend to do this too. It's just human nature. So yeah, let's move on. Okay, so the closure function, okay, according to the first rule of the closure function, states that the item that on which we are applying the closure function is in ik. The item itself should be part of the state, and now along with the item I'm gonna have some other items too in the state. And rule 2 of the function states that if the item I looks something like this, for example, if the item I looks like this, a derives alpha dot b beta. So if the item looks like this, meaning that there is a non-terminal after the dot. So I do not care what alpha and beta can be. Alpha and beta are strings of grammar symbols, or it can also be epsilon, but I do not need to worry about what alpha and beta are. I only need to look at the non-terminal after the dot. So you see that after the dot, there is a not a terminal, there is a non-terminal. So when there is a non-terminal after the dot, what we are supposed to do is we need to add the production rule of the non-terminal with a dot at the front of the production body in the state ik. So that was our task. Our task was when we have a item where the dot is before a non-terminal, then I had to add the production rule for that non-terminal in the state ik. But to make it an item, I need to put the dot somewhere in the production body, and the dot has to be put before the production body, meaning that I haven't yet visited any part of the string of the production body yet. So this is how we used to add items in the ik state with the help of the closure function. Now here we can see that in case of, since this is the closure function for LR1 automation, you can see that here in the item there will be two components to it. So previously in the SLR1 version of the automation, there was no look ahead. But since we are using an LR1 automation, we are going to have a look ahead, and the look ahead is going to come from the subs is going to come from the follow set for A. Look ahead is what? Is a follow, right? Whatever follows A in a sentential form is the look ahead for A, right? And this look ahead should be a subset of the follow set for A, because the follow set for A defines all kinds of possible look aheads that might come directly after A in any sentential form, right? So this is the generalized concept behind follow sets, right? Follow is a terminal that might come after that non-terminal in any sentential form, right? So this look ahead symbol, small a, this is a terminal, and this terminal is the terminal that directly follows a in this sentential form, this particular sentential form. So I know that the look ahead for capital A is this small a, but I need to figure out the look ahead for this capital B, right, in order to add it as an item in the IK state, right? Because in order to make it an item, I need to have two parts to it. The first part, the core is already present, the core is there, which is obtained in the same way as we obtained the one in the LR0 automation. But the look ahead needs to be obtained too. Otherwise, we cannot make it an LR1 item. So there should be one kind of way, a kind of process through which we can know what's gonna be the look ahead for B, right? That's our problem. The problem for us is to find the look ahead for B so that we can add it as an item in the IK state. So now one way to figure it out is that suppose the context free grammar from which this production rule A derives alpha B beta is derived has a start symbol S. So S is the start symbol. And suppose after few or more states, so putting a star on the derivation symbol means that I have obtained this sentential form after more than one state. It's not obtained in the first step. It means that I did not obtain it in one go. After many several states that are hidden underneath, I have obtained this sentential form here. All right, in one or more steps. This star symbolizes one or more than one step or one or more steps. So suppose from the start symbol S in the process of derivation, I have uh, figured out, or I have reached this sentential form which looks like this. I have reached a sentential form which looks like this. Sigma A A X. So this is a sentential form that I have reached in the process of derivation from S, like after several steps. This is a sentential form that I have figured out. Okay, I have reached. Now here we can see that in this sentential form, I do not need to worry about what sigma is, because sigma denoted by a Greek letter is again is bunch of grammar symbols that may or may not be epsilon, but I do not need to worry about what sigma is. Now, as we have said that bottom-up parsers always follow a rightmost derivation technique. The rightmost derivation technique is followed. So can I say that whatever non-terminals was after A has already been converted to their terminal forms, has already been expanded to their terminal forms, and now the next non-terminal to expand is A? Can I say that? Because again, rightmost derivation technique always expands the rightmost non-terminal first. So since the rightmost non-terminal now is A, I can say that all non-terminals after A has already been expanded to their terminal forms. Can I say that?
Yes, ma'am.
Yes, I can. So now A is the next non-terminal to expand. So then in the next step, so here notice that in the derivation symbol, I'm not putting any star here or any kind of symbol over the derivation technique, meaning that I'm obtaining this sentential form in the next step, in the immediate step after. So that is why no star is here. Now, if I am to expand A, then I have to look for the production rule for A, right? And the production rule for A is this alpha B beta, right? Alpha B beta. So now in the next step, I'm expanding A to the production body for A, which is alpha, B, and beta. So expanded A. Then I have A, and then lastly I have X. Okay. So this is the next tangential form in the process of derivation that I'm obtaining after expanding A, right? That I can say, right?
Yes, ma'am.
Right? Yes. So there is no harm in saying that. Now we can see that the goal for all these things the goal for these things that we have written, the goal was to obtain the look ahead for B. That is why we have derived all those things from the stat symbol. I need to find the look ahead for B because the look ahead for B is needed to make the production rule for B an item and part of the IK state. So the look ahead for B should come from this portion here, whatever lies after B, right?
Yes, ma'am.
Yes. And we can see that whatever lies after B is actually a string called beta AX. Beta AX. Now, beta and A are fine, but X. So, X is a string of terminals that have been derived after breaking down the non terminals that were after A. Alright. So X is a string of terminals that was obtained after breaking down all the non-terminals after A into their terminal components, right? So I do not need to care about what X is because in no way can I get X as a look ahead symbol skipping A, right? Because A is a valid terminal, and if I am to find the look ahead for B, there is no way that I'm gonna get any terminal from the string X skipping A, right?
Yes, ma'am.
So I can say that X should not be part of the look ahead symbol that is after B, that is for B, the look ahead for B. So I can say that the look ahead for B lies somewhere in beta A, this portion, this bit, right? So can I say that the look ahead for B is actually first of beta A? Can I say that?
Yes, ma'am.
Yes, I can. Because now beta, if beta is epsilon, then the look ahead for B is A. The look ahead for B is A, which is also the look ahead for A, meaning that the look ahead for A is copied and pasted as the look ahead for B. If beta is epsilon, right? If there is nothing after this B. But if beta is not epsilon and beta is some bunch of terminals and non-terminals that is generated from A, then the first of that beta is actually acting as the look ahead for this B. So that is why first of beta A is going to be the look ahead for B. Let's suppose the first of beta A is this terminal B. So if it's this terminal B, then I can say that here the item for B should be P derives dot gamma comma B. Okay, which is coming from first of beta A. Clear?
Yes, ma'am.
Yes. So now the closure function is described. The closure function is explained completely. This is the major difference between the two kind of automations for SLR1 and LR1, LR0 and LR1 automations. And the goto function remains the same. The process is also same, which is just to mark the transitions between the states. So if I have a item I, sorry, if I have a state ij, or suppose ik, and if I get a grammar symbol x, then I'm going to move to a state ij. Okay, where k and j, these are all um, integers of the form like 0, 1, 2, anything. Okay. Now, um, what was the changes that were made when a goto function is called? That is also the same, which was that if I have a state where an item I looks like this, so I'm at a state ik, and I have an item I that looks like this, where I is equal to, suppose a derives alpha dot x beta comma a, and there could be few other items along with this item I in the state ik, it doesn't matter. Now if I am to have a transition based on the grammar symbol x, then some kind of changes should be made to the next state ij over the item I, right? Otherwise there is
Yes,
no
ma'am.
point in having a transition. So the changes that will be made was that I was converted into I prime, and I prime looks something like this: a derived alpha x dot beta comma a. So here, when I have seen the grammar symbol x in my input, then the next stage for the state ij is to shift the dot after x. Now when the dot was before x, it means that I haven't seen x yet. But when the dot moves after x, it means that x has already been seen by us from the input string, and the dot should move after x, before beta. Now see that when I was dealing with LR0 automation, the look ahead or this A right here was not part of my item previously. This came in LR1 automation, right? Because in LR1 automation, all items are gonna have one or more look aheads. So here we have a look ahead for A. Now notice that when we are transitioning for the goto function, no changes are made to the look ahead. The look ahead remains the same, right? You see
Yes, ma'am.
that the dot is being shifted after x, but there are no changes made to the look ahead for the item I prime, right? So that
Yes, ma'am.
is why the look ahead will not change in case of go to transitions. Look ahead, the concept of look ahead will only come during closure. During closure, we are gonna have to create look ahead symbols for the items, and those look aheads are gonna remain the same throughout the process of iterations. Clear?
Yes, ma'am.
Okay. So clear. Now we know how to compute an LR1 automation. So let's move on to a practice problem. So this is a yeah. Okay, is this automation visible to everyone?
Yes, ma'am.
Can you see the components, every component?
Yes, ma'am.
Okay. So maybe I can zoom it a bit. Okay. So this is a LR1 automation. You see that Every item here has two parts, the core and the look ahead. Okay. So this is a sample grammar. It has three production rules, one for S and two for C. Okay. So the first step is to augment the grammar. If you are to augment the grammar, then we need to add a new start symbol, just the same way as we did with the SLR1 parsing. So adding a new start symbol means adding a new S prime. And the production rule is gonna be that the new start symbol is gonna point to the old one. So S prime to S. And the next step was to mark the production rule starting with 0 on an incremental basis, right? So we mark the new production rule with 0, and then the next one with 1, and so on. Now, the first item on which the closure function is gonna be called is going to be this one. Um, S prime derives dot S, right? In case of SLR1, this was the item on which the closure function was called. Why this was the item? Because the dot is before the start symbol, meaning that I haven't yet visited any part of the parse tree yet, right? So the dot is before the start symbol, meaning the parse tree is yet to be visited, and nothing of the parse tree has been seen yet. So this would have been the first item on which the closure function would have been called, which would give me a state marked I0. Now here in case of LR1 automation, the item will be the same, but again for an LR1 item, two components need to be there. The core is present, which is this one, but I also need a look ahead. Can anyone tell me what's going to be the look ahead symbol?
Ma'am, dollar, ma'am?
Yes, Hasnat, right?
No, ma'am, Maruf, ma'am.
Maruf. Yes, Maruf, thank you so much. Yes, Maruf is correct, which is dollar. So why dollar again? Because um S prime's follow set is gonna be acting as the look ahead here in this item. Now S prime will have a follow, which is dollar, because by this item I mean that in the parse tree, if you visualize it in this way, so it means that the dot is here, right? So the dot is here, and the follow for S prime will always be dollar by default. Here, this is the only follow that S prime, the new start symbol augmented by us, has, which is dollar. So that is why dollar will be the look ahead for this item here. So I am going to, is the background noise too troublesome?
No, ma'am.
Hmm?
No, ma'am.
No. Okay.
সমস্যা
Thank.
হচ্ছে না খুব একটা.
Okay. There should be a law on not to have these kind of hectic construction work after people start residing in the apartments. It's so troublesome, problematic. Okay. Now, moving on. So, you see that here the item S prime derives dot S comma dollar was the item on which we call the closure function. Now, again, according to rule 2 of closure function, we need to check whether there is a non-terminal after the dot. So this is what I have to look for, right? Because this is the rule 2 for closure, which states that if I have a non-terminal after the dot, then I need to look for the production rule for that particular non-terminal and add it as an item to the state ik. So again, I check whether there is a dot after the non-terminal. So yes, capital S is a non-terminal, right? So dot after the dot, I have a non-terminal. So I need to look for the production rules for S, and the production rules are given here in the grammar. So there is only one production rule for S, which is S derives CC. So I add the production rule. Again, the dot is to be put at the front of the production body by default. So I put it at the front. And then after the comma, I need to find the proper look ahead symbol for S, right?
Yes, ma'am.
Yes. Because I need to add append it as an LR1 item, not an LR0 item. So I need to Look for the look ahead. Now again, the look ahead according to this rule comes from where? I'll first of beta A, right? So
Yes, ma'am.
whatever string is after B is my beta. So this is my beta. And where does A come from? A is after the beta, separated by a comma between beta and A, right? There is a comma separator between the string beta and the look ahead A, right? And
Yes, ma'am.
first of beta A would have been my look ahead for B, this B, right?
Yes, ma'am.
So I need to look at the string of grammar symbols that is present after B, which in case is S here, and I need to look at the A, which is the look ahead for S prime. So beta is epsilon because nothing is after S, right? Nothing is
Yes,
after
ma'am.
S. And after the comma separator, the look ahead here is dollar, right? So first of epsilon dollar, since beta here is epsilon, is what? Dollar,
Yes,
right? Also, if you want to see a pictorial representation of the same, you can do it like from S prime, right? I'm getting S, right? And since here after S prime I have dollar, but here we see that from S prime I can derive S, and along with S is not associated with any grammar symbol whatsoever in the right of it, right? In the rightmost part of the production body, rightmost part of S, there is no grammar symbol whatsoever. Means that this part is empty, which means this is epsilon, right? So when this is
yes,
epsilon, then to find the follow for S or the look ahead for S, I need to look one step back, or I have to backtrack one step and see what follows its parent or what follows S prime. What follows S prime is dollar. So that is why S is also followed by
dollar.
dollar. So that is why we're gonna have dollar as the look ahead for S. So you see that dollar here is the look ahead for S. Clear?
Yes, ma'am.
Okay. Now, since the rule number two for closure is gonna be performed on an iterative basis, right? It's an iterative rule. So I need to apply rule number two as long as I have at least an item where there is a non-terminal after the dot, right? This is an iterative approach. So now we see that in the second item here, after dot, I still have a non-terminal, right? So I need to repeat rule number two again, which states that I need to add the production rule for the non-terminal which resides after the dot, right? So after
Yes,
the dot, I have capital C, which is another non-terminal. Then again, by rule number two, I have to add the production rules for C. Now you see that C here has two production rules, unlike S. So when we have more than one production rules for a non-terminal, I have to add all the rules for it. So two rules are applicable and two rules are added here with the dot at the front. See that dot CC dot P. Here.
yes,
And now the look ahead, C and D. Where are they coming from, right? So this C here is the non-terminal on which we applied the rule number two, right? Which is acting as B here, capital B. Beta is whatever string of grammar symbols are after B. So the string of grammar symbol is after B consists of only one non-terminal, which is C, right? And A here is the look ahead, which is dollar, right? So alpha
yes,
dot B beta comma A. So beta A is actually what? C dollar, right?
yes, ma'am.
C dollar. So if I am to find the first of C dollar, I need to find the first of C first, right?
Yes, ma'am.
This is a non-terminal. And by looking at the production body, it is evident to us that first of C can be C and D, because you can see that both of the production bodies for C start with the terminal, right? When it starts with the terminal, then according to rule number one for the first function, that terminal itself is first of that production rule, right? So
Yes,
since
ma'am.
they both start with terminal, so C and D are going to be the first for C. So now if C and D are first for C, then I do not need to look at dollar anymore, because whatever strings are gonna appear for C dollar are gonna be derived from C dollar, it's gonna always start with C or D, right?
Yes, ma'am.
So let's see. So here we can see that look ahead for the production rules for C have C or D as their look ahead, right? Look ahead are C or D, C or D and C or D both, right?
Yes, ma'am.
If you want to picturize this in with the help of a parse tree, you can also do that. So if we are to visualize this with the help of a parse tree, you can see that here as well the rule holds. So okay. So we started the parse tree with the start symbol at the beginning S prime, and the follow for S prime was dollar. Then in the next step, I expanded S prime to S according to the augmented production rule, and then from S I got what? I got CC, right? I got CC according to this production rule for S. So from S I am having CC, C, C, and the dot was here, and here the dot is here. So when the dot is here, you can see that I am to find the look ahead for C, because I'm adding the production rules for C in the next stage, and that is why I need to find the look ahead for C or whatever follows after C. Now, whatever follows after C is actually coming from this C and this dollar, right? It's coming from here, right?
Yes,
Because
ma'am.
this bit here is epsilon, so that is why I need to backtrack and see what terminal follows this C, and the terminal that follows this C is dollar. So that is why follow for C or look ahead for C should come from first of C dollar. Now, if this C gives me C or D, then I do not need to worry about dollar anymore, because strings will start with C or D. So follow for C will be C or D. Clear?
Yes, ma'am.
Yes. So now C or D is the look ahead for capital C. Okay. Now, do I need to continue with rule 2 anymore? No, rule 2 for closure function is halted here, because I can see that the items that I have found at the end, all the items have a terminal after the dot sign. So I do not have any more non-terminal to expand. So that is why I halt the rule iteration process here. Okay.
Yes, ma'am.
Okay. So this is my state I0. This is the starting state. Now, according to the go to function, I need to put the transitions from the state, right? Now, the go to function says that I will put transitions from state I0 only for the grammar symbols that are after this dot. So, after this dot, I have S. So, there is a transition for S. I have C, there is a transition for C. I have small c, transition for small c. I have D, transition for D. Here, four transitions I have. And the
Yes,
go to rule also states that there will be some changes made to the item on which the transition is being called. So I am applying the go to rule here on this item. And when I'm applying the go to rule here, S is my grammar symbol. And the go to function states here that when the grammar symbol is being seen by us, is being visited by us, then the dot of that particular item is going to shift one uh, grammar symbol right? The dot is going to shift after X, right? And all the other things are going to be the same. No more or no further changes should be made to the item. The only change that's going to be made to the item is the position of the dot, meaning the dot should shift one symbol right. That's it. And no changes you can see are made to the look ahead, right?
yes, ma'am.
So now moving on, we see that when I am calling the go to function on S on based on this item, the dot shifts after S and the dot is here, and the dollar sign which was the look ahead remains unchanged, right? It's unchanged. Okay.
Yes, ma'am.
And now if we apply the closure function on this item, Rule number 2 will no longer be applicable here because again, um, according to the closure function, I can only apply rule 2 when the dot precedes a non-terminal, right? The dot precedes a non-terminal. But here I can see no non-terminal after the dot. So that is why this item will be a sole item, sole member of the state I1. Okay?
Can
Okay.
you repeat the thing?
Understood?
No, can you please
I
repeat,
said
ma'am?
that here I can say that after the dot there is no non-terminal, right, for this item.
Yes, ma'am.
So that is why I will not be applying rule number 2 for the closure function. That is only applicable when there is a non-terminal after the item, right?
Yes, ma'am. Yes.
Since there is no non-terminal after the item, so this item, this state will be a one item state, single item state, and no other further items will be added to this state. Clear?
Yes, ma'am. Yes,
Okay. Then in the next step, when I'm calling the goto function for C, the non-terminal C, then the dot is going to shift after C. Now, if the dot shifts after C, then the item should be as there as C dot C, and dollar should be the look ahead, right? The look ahead should not be changed, but the dot is going to shift after C. So that's what happened. And now over this item, if I call the closure function again, then I can see that I need to call rule number 2. I need to apply rule number 2 because again here after the dot I am having a non-terminal. And when I have a non-terminal, I need to append the production rules for that non-terminal, right? So
yes, ma'am.
that's what I did. So if this is my C and I'm calling the production rules for the non-terminal C, these two are the production rules. I add them. So they are added and the dot are at the front. Dots are at the front. And what about the look ahead symbol? The look ahead will be
Dollar.
first of beta A, right? So if this is my capital C, beta here is epsilon. There is no beta, right?
Yes, ma'am.
Alpha dot B beta. So this is my B, which is C, but beta here is epsilon because nothing is after C and A is this, right? So
Yes, ma'am.
since beta is epsilon, A is my look ahead, dollar dollar gets appended here. If you want to visualize this with the help of a parse tree, you can do so too. That from S dash I have dollar, from A, then I have S, then C dot C. Okay, and now since I am finding the look ahead for this C, now I'm finding the look ahead for this C, not this one, because the dot precedes this C. So if I am to find the look ahead for this C, I need to check for whatever follows C in the sentential form, and whatever follows C is actually just this dollar sign. Here,
Yes, ma'am.
okay, here. So that is why dollar is appended as a look ahead. Now in this way, all the other items are appended and the automation is constructed, and the automation is halted when all the items in the states we got at the end have dots at the end of them, at the end of the item. So you see that dot here, dot here, dot here, right? Now there's a special case here which is a self loop. This one, self loop. You see that there is a self loop for C. Okay, so you see that from the state I0, when I am having a transition for the small c, then the dot moves after the small c and the dot is before this capital C. Look ahead is the same. Now, if I call the closure function on this item, the first item of I3, then I can see that rule number 2 will be applicable here because after the dot I have a non-terminal and the non-terminal C has these two production rules. So I append the rules with the along with the previous item and the dots are at the front. Now according to the rule number 2 for closure, alpha dot b beta, beta here is epsilon because nothing follows this capital C, and A here is C or D, so C or D will be appended as the look aheads, right? Because beta is epsilon. Here?
Yes, ma'am.
Yes. So now in I3, if I make a transition for small c again, right, there will be transitions for capital C, small c, and D. Now if I make a transition for small c again, then what do I get? So let's make a transition for small c. If I make a transition for small c from I3, so the item that will be found is this C dot, then capital C, then C or D, right? This is the item that I'm finding, right?
Yes, ma'am.
And now again, rule number two will be applied for the closure function because after the dot I have a capital C which is a non-terminal. So I add the production rules for C again because again this is a non-terminal. So there are two production rules to C, 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 and D. Okay?
Yes, ma'am.
And now here you can see that after C, beta is epsilon because nothing is after C, right? Nothing is after C. And alpha dot B beta, beta is nothing, right? So this is the look ahead that's gonna be the look ahead for C here, right? Because beta is epsilon. So A here, the look ahead for C is copied and pasted in these two items, right?
Yes, ma'am.
Okay. So now aren't these the same items that are the items in I3? And the same?
Can you repeat the question?
Yes?
Can you please repeat the question?
Yes, I said that aren't these items the same items that are in I3?
Yes, ma'am.
All the three items are the same, right?
Yes, ma'am.
So whenever you make a transition for C based on these three items of I3, you are gonna keep on having the same items over and over again. Here.
Yes, ma'am.
So that is why there is a self loop here in I3 on C, meaning that I'm gonna be having the same items over and over again as long as I'm getting C as an input. So that is why there is a self loop here in I3 for C. Clear?
Yes, ma'am.
Okay. Now for D, if I make a transition for D, then what happens? The dot gets shifted here and the look ahead remains the same. Now this item here was previously generated when I was having a transition for D from I0. So from this item, when I was having a transition for D, I4 was obtained. So since this item was already generated and was already a part of item I4, state I4, so that is why the same state is not again created for eliminating redundancy. That is why we are pointing the transition from I3 for D to the state that was created previously, which was I4, because it had the same elements in it. Clear?
Yes, ma'am.
Okay, so these two are the I would say some minor new things, new stuff that came in this grammar. But apart from that, all the other things are the same. All other things are the same as SLR1. Only the closure function will be changed a bit. So is this clear to you all?
Yes, ma'am.
Everybody clear?
Yes, ma'am.
Any questions?
No.
No questions. Okay, so now the automation is the thing that is a bit different. Apart from that, you the LR parsing algorithm, the table, action table, go to table, everything will be the same. So we will do some classwork on Thursday and Saturdays. Thursday and Saturday, I have reserved these two classes only for quizzes and classwork sessions. So please try to be present in both the sessions because the classworks are gonna be added to um, your marks, to your overall marks. Okay.
Yes, ma'am.
Okay, so if you don't have any questions, then we can end the session here. So see you on Thursday. We have a quiz on Thursday, and we're gonna also have another quiz on Saturday. I will post the syllabus. Hello.
Yes, ma'am.
Okay. Okay. Then okay. See you everyone. Allah Hafiz.
Assalamu alaikum, ma'am.